Alrighty, so we're going to learn reverse Polish notation. Whee! So there's another way to say it. People sometimes call it postfix notation. There's also, in case you care, there's something called prefix notation, and the stuff that we actually use in real life is usually called infix notation. Infix notation is like saying 3 plus 2 times 6, right? And then postfix notation, which would be RPN, is 3, 2 plus 6 times, and prefix I think would be plus 3, 2 times 6 maybe? Or something else. I don't actually know because I don't do prefix notation. I just do postfix because that's what all the cool kids do is postfix notation. Anyway, where was I going with this? Yes. Okay. So RPN was invented, well, kind of invented in the 1920s by this Polish person that I can't pronounce his name, but it's something Lukasiewicz. He invented like just regular Polish notation, which I think is going to be the prefix version. And then in the 1950s, there was this guy who was a computer scientist and a philosopher because you could do that. And his name was Charles Hamblin. And he made reverse Polish notation. And it's really cool because basically there is no parentheses. So like I said, you have 3 plus 2 in parentheses times 6. But another way to do it would be to do it like this. So there would actually, if everybody used RPN or PN, there would never be any issues of like order of operations because the order of operations is this natural inside. So it kind of works like a stack. So let's say I have 5 plus 2 times 3. Okay. So in RPN, we would go 5, 2 plus 3 times. So how this works is that you kind of have like a stack. And every time it sees an operand, it applies it to the 2 previous numbers. Okay, so what this would look like is, again, I'm kind of taking a look at this here. I would put on the 5, and then I'd put on the 2, and then I put on the plus sign. And the algorithm goes, oh my gosh, there's a plus sign. I'm going to apply it to the 2 previous. So I'm going to do 5 plus 2. And so the 2 and 3 thingy, sorry, not the 2 and the 3 thingy. The 5 and the 2 thingy becomes a 7. So you have this new stack where it puts the 7 on the stack. All right. So you've thrown this on the stack and this on the stack and this on the stack. Now you're putting the 3 on the stack. So 3 goes on the stack, and then you put the times on the stack, and it goes, hey, we got ourselves another operand. So we're going to apply the operand to the 2 previous terms in kind of reverse order. So we go 7 times 3 is 21. And then that's the only thing left on the stack. So your answer is 21. Sort of? Kind of. Okay. Let's do it in a slightly different order then. Let's say that we had 3 times 5 plus 2. So it's the same problem, but it looks slightly different. So in RPN, it would be 3, 5, 2 plus times. Okay. So I just absolutely love RPN. It's super, super cool. So I start with the stack and I'm putting on the 3. Okay, so I'm actually going to do these like this. So I put on the 3, I put on the 5, I put on the 2, I put on the plus sign, and now it goes, oh, yay, I'm going to apply that to the 2 previous terms. So what happens is, it comes over here. Now the 3 stays there at the bottom because it was already there. And then the plus sign looks at the 5 and the 2. So it goes, okay, 5 plus 2 is 7. So it's going to throw a 7 on there. So that 7 comes from that. All right, and then we go back to our statement up here, and we see a times sign. So we put the times sign there, and then the system goes, oh, look, there's a times sign. So now I'm going to take the 3 times the 7, and I'm going to get 21. Okay, it's super fun. I don't know how to describe it, but for some reason, I just absolutely love doing the infix notation. So if you like to think about it as pushing and popping off of a stack, sometimes that really helps people understand what's going on. Another way, like I said, is if we have 3, 5, 2 plus times, you kind of read from left to right, and every time you see a operator, you go to the previous 2. So that would be 3 And then 5 plus 2 gives me 7. And then I just write out the rest of the expression. And then I say, oh, then I have 3 times 7. And so 3 times 7 is 21, like that. All right, so let's try this one. For practice with the evaluation, let's do 8, 5 minus 4 to the 8, 12, 5 minus times plus. So it's super funny because I do teach this face-to-face, and like at the beginning, everybody's eyes are crossed, and by the end, they're like, this is so much better than any other way of doing math. And I'm like, this is how you know people who in their heart of hearts are like EEs or computer science or mathy people, because they just get so excited and so happy about this. Okay, so as I go through, the first thing, I just go left to right. Every time I see an operator, I apply it to the 2 previous. So I see the negative sign, and I just go 8 minus 5. Don't get into this discussion of whether it's 5 minus 8. It's not. It's 8 minus 5. So 8 minus 5 is 3. And then literally, I'm just going to keep writing the rest of this on here. 12, 5 minus times plus. All right. Then I go D to D to D to D, found another, well, actually, I wasn't really doing that. I was going this way. I found the other one, and now I go 2 back because an exponent is applied to the 2 previous terms. So 3 to the 4 is 81. And then I go 8, 12, 5 minus times plus. And then I go do to do to do to do to do to do. Oh, there's a minus sign. The minus sign gets applied to the 2 previous terms. So the 81 and the 8 just kind of hang out. And then I have 12 minus 5 is 7. And then I just keep writing the doot to doots. Actually, I'll do that in that color so you see what's going on. Doot to doots, like that. Yay! All right. And then I'm going to go do to do to do to do to do. Oh, look, there's a times. Apply it to the 2 previous terms. You kind of seeing what we're doing here. So the 81 stays the same. 8 times 7 is 56. And then I have the plus sign. And then I go do to do to do. Oh, look, I applied that to the 2 previous. So it's 81 plus 56, which gives me 137. Okay, the reason that we love infix is once you kind of get into the swing of it, you can totally just like see how easy this would be to teach it to a computer. Okay, it's super easy to teach to a computer the idea of push, 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 push. If it's an operator, pop and perform the operation. Whereas if you're trying to explain to a computer of like, okay, so it's 3 times stuff, but you don't want to do the 3 yet, you kind of like want to wait on the multiplication until you see the parentheses. And like maybe you could have this long conversation with your computer about it, but then whenever you get to something like, 5 to the 3 plus 7, minus, to the square root of 3 plus 1, something like that, trying to explain to a computer the order in which to do this would be pretty complicated. Whereas in postfix in postfix and RPN, it would just be like, let's see, 3, 5, 3. Oh, I keep using the letters 5 and 7 again. Let me just change them to 4 plus 6 and 7 and square root of 8 plus 9, just so that the numbers are different. It would be 3, 5, 4, 6 plus exponent times 7 minus 8, 9 plus square root plus. Okay, which is basically telling it, okay, so as you're going along, you're going to do the 4 plus 6 first, right? So you do the 4 plus 6 first to get the 10. Okay, and then the next thing you're going to do is you're going to do the 5 to the 10. And I know that, like, I'm not going to actually calculate this because it's too much work. And then the next thing you see is the times. So now you're going to go 3 times that. Okay, and then the next thing you see is the minus. So you're going to go that minus 7. And the next thing you see is the 8 plus 9. And then you're going to take the square root of that, and then you're going to add it to the thing that you just had. And so that's kind of how that works. I'll do another example that's a little less crazy, but I just want you to know that it's a lot easier to explain to a computer how to do stuff in RPN than it is to explain to them how to do stuff with parentheses, just because, I mean, even trying to explain it to a normal person, you're like, okay, yeah, but then you've got to wait because you don't want to add this until you add this. And that's kind of like what we're doing. All right, so I'm going to give you 2 to play with. Here we go. Okay, so these are the two that you should try, and I strongly recommend you pause the video and then go and try and work these out. And then if you kind of get stuck, just remember you just keep going until you find a operator, and then you apply it to the two previous ones in the order that you see the numbers going from left to right. Okay, so again, ideally, pause the video and see how far you can get. All right, so you totally worked that out, right? All right, so here we go. Go doop-de-doop-de-doop-de-doop-de-doop. Oh, here's a plus sign. I'm going to apply it to the 5 and the 3. Yay! So what I had before is I had 9, and then 5 plus 3 is 8. And then I have a 2 and a 4 and a ta-da and a minus and a plus. All right, now I'm going to start again. Oh, look it, I've got this. I'm going to apply it to the two previous terms. So I have a 9 and an 8, and a 2 to the 4 is 16. And then I have a minus, and then I have a plus. All right, now I'm going to do this again. Oh, look, it's a minus. I'm going to apply it to the two previous number thingies. All right, so I have 9. 8 minus 16 is negative 8. So this is like I don't really need to put parentheses on it, but that's not minus 8. That's a negative 8. And then there's a plus. And now I'm going to go Oh, look, there's a thingy. I applied to the two previous ones. 9 minus 8 is 1. Yay, you got it. Okay, and now as you're doing this, you're like, this is kind of stupid because why would I ever do it like this? Well, you wouldn't. Like, you wouldn't. What I'm trying to do is show you how the computer thinks about it, because whenever you want to tell a computer how to do this, this is how you tell them how to do it. You're interpreting for them. That'll be the next video where we go backwards. But first of all, you kind of got to understand how it works. Again, not because in real life anyone's going to ever give you an RPN thing, but I honestly, it's so silly. I use it all the time on my calculator at, like, even at something like at the hardware store. If something is, I can't think of a good example right now, but let's say I need 5 and 5/8 of something, and for some reason I need to put it in my calculator. Let's pretend I just have no idea what this is. I have an RPN, and so if I was going to do this on a regular calculator, I would have to mentally be like, okay, so I need to do 5 divided by 8, and then I need to do plus 5 because everything has to be in order. But since I have an RPN, I can go 5, 5, 8 divided by plus, and it just comes out that quick. And this is a dumb example because it would be like if I had 5/8 plus, 3/4 plus something else, and 8 and 9/7 or whatever, being able to put it into my calculator, that because for some reason I've decided that I have an RPN calculator always at hand, but not something with parentheses, it just makes things a whole lot faster. It's really fun. But nobody's ever going to give you an RPN problem to work out unless you're taking a class where they make you do this kind of stuff. All right, so here's my second example. I'm going to go across. Yay! 4 times 3 is 12. And now I'm just going to rewrite all these. All right, now we'll do the next one. Oh, look, it's a minus sign. I'm going to apply it to the two previous numbers. So I have 12. 8 minus 2 is 6. And then I have the rest of these terms again. This is fun. All right, let's do this again. Oh, look, a division sign. I'm getting tired of me doing this because I'm kind of tired of listening to myself. I put down the 2, and then I put in the rest of the numbers. So here we go. Ooh, my goodness, look how far I'm going before oh, there it is. So I have 2, 4, 125. What's 5 plus 20? 25. I am super good at math. And then and and I'm gonna keep doing this. This is super fun. This is, Oh, now the square root, we're smart enough to know that a square root just applies to the first term behind it, not to the previous two terms. That would have to be something that we specifically threw into our code and let them know that. The square root of 25 is 5. Ooh, I'm trying to be all color codey and All right, and then what am I at? Blue again. Division. This is super fun. All right, so I've got 2 and 4 and 125 divided by 5. I feel like that should be 5. Yeah, I think so. 5, 2, 4, and 5, I believe. Yeah, I'm down. No, not 5. 25. 25 is what I'm trying to say, because there's 25 of them. I mean, I was doing it backwards. I was automatically. Anyway, it doesn't matter. And then times, and then plus. Okay, and then what am I going to do? Green. All right, and then I have 2, and then 4 times 25 is 100 because I'm super good at that kind of math. And then I'm going to do one more time and back on red, and I go and then 100 plus 2 is in fact 102, and I'm done. And that's how you do that. And again, it's kind of silly to do it as a person. This was not originally designed for people to do. This was arranged for computers to do. So I'm teaching you how to think like a computer because that's what all the cool kids are doing. But yeah, that's fun to do forward.